about proportionality and about similar triangles. Okay. Let's looky here. I've got two angles that are the same, and two angles are the same, making the triangle here. These two angles are the same. Okay, if I know these two angles, notice that the triangle sum theorem tells me what this angle is, 180 minus this one and this one. If these two angles are same, the green-blue and the yellow-blue, then when I subtract from 180, I will get the same angle measure from here. So what we see is that if we have only two angles, then we know that the triangles are similar, that they are the same shape. Remember previously we knew if we knew all three angles were the same, we knew in a triangle, we knew that they were the same shape. So now we know we only really need two of the angles. We know these two are the same. We subtract both from 180 by the triangle sum theorem, and these must be the same. So that gives us that all three are the same, therefore the two triangles are congruent. That would be the angle-angle postulate. Let's see how this can help us. First off, let's look at this example. Flagpole in Laredo, Texas. Okay. Notice that we have triangles here, although we don't have items for them. They're marked here. The line coming down from the top of the flagpole to the ground represents the sun ray, which is a straight line because it's light, coming down also at the top of the man's hat and down to the ground. The shadow represents the absence of light, and the shadow on the ground gives us the third side of our triangle. So here we have two triangles with the flagpole, the shadow, and the light, the man, the shadow, and the light. Are these triangles similar? Yes, they are. They have the same right angle, and they have the shared angle here. They have two angles. Angle, angle, they are similar. Once they're similar, we know that the sides are proportionate, so we can write a proportion. Remember to be careful when you write a proportion. Always write two things that you're comparing under two circumstances. So here we're comparing the flag and the guy with regard to the shadow that they cast and the height. Write words, rehearse in your head to make sure that you know what you're doing. The flag shadow is that. The guy's shadow. Oh, well, wait, look, here it says 54 inches, and here I've written 4.5. Notice that they're different units. All of these are feet, and these are inches. You can choose either to go to all feet or to all inches. It doesn't matter. Sometimes one of them is easier than the other. Here I chose feet. Normally, depending upon the circumstances, but normally it's best to choose whatever unit is smaller. Like an inch is this big and a foot's like this big. The inch is smaller, so go for the smaller unit. Not the smaller number necessarily, but the unit that itself is smaller, and that'll usually, most of the time, give you the easiest way to work on the problem. Again, you're going to have the units right. A ratio will need to have the same units to be a valid ratio. Some of these to look. Let's see. Is this one? Are the large triangle and the small triangle, are they similar? Yes, they are. They share an angle and then have 65 degrees, so they are similar. Two angles, angle, angle, therefore they are similar. Remember, when you write your similarity statement, they have to be in order by the corresponding vertices, just like in a congruency statement. Okay, what about this one? Are they similar? Well, first off, they don't look very similar, but let's investigate a little further. The top smaller triangle is 85, 45. You add that together, and that leaves 50 for the unknown angle. Do the same thing in the bottom. That leaves 45 for the unknown angle. Remember, for similar and for congruent, it can be the mirror image. This is the mirror image. It's been flopped over. Okay? So they are similar. They both contain the same angles. So you can write a similarity statement. When you do it, make sure you do it in order. So you can put them any order you want, but if I go small, medium, large, that would be X, Z, Y is similar to U, W, Y. Remember, the corresponding vertices have to be listed in the same order. Here we have a picture, and we're asked to find out how big the image is on the ground. This is, you can tell it's an old book because it says you hang a camera from a blimp. If we did it now, we'd just send up a drone. Notice that you got similar triangles here. We have parallel lines because that's the way it's constructed. Parallel lines with transversals mean alternate interior angles that are congruent. So this angle is congruent to that one, this one to that one. You have similar triangles. You can make up a proportion based on the similar triangles. You might recall the Girl Scout, Boy Scout scenario that we had before with congruent triangles. It's much easier actually with similar triangles. We had to pace out the paces to find the midpoint to be able to do it as congruent triangles. But as similar triangles, we don't have to do that. We get the same direction with our compass, and then we can just do the two sides, and we could very easily figure out what it is, make a proportion because they're similar. These are parallel alternate interior angles, are congruent, make a proportion for the unknown side, which is the distance across the river. Here endeth the lesson.